My last job today is to introduce our next speaker. His name is Marc Andrews, and he is the Vice President of the Watson Financial Services Solutions, an IBM Industry Academy, I can't talk anymore, Academy member, sorry. So I'm pretty excited because this is going to be a little bit different. He's going to be doing a demonstration today of the Watson Artificial Intelligence. So over to you. Great.
Thank you. So I just need to get set up here, but what we're going to be doing for this session is a little bit different. And I'm actually going to, normally in these sessions, you are always concerned if people are on their phones or things like that, but I'm actually going to ask you guys to make sure you pull out your phones for this session. So we're going to do some polls and some audience participation here. And we're going to be using Slido. I don't know if any of you used this before, but if you have the app, you can use the app. If not, you can just go to slido.com and hit pound Watson when you get there. And you'll see some, you'll get access to a survey. There's nothing up there yet, but you'll just see a slide up there that's ready to go and see things. So what I was going to do today is give you a little bit of a demonstration of how we see organizations starting to apply technology or starting to apply artificial intelligence and cognitive computing into this environment. And one of the things that we have seen here is that there's not a great understanding of what differentiates cognitive systems and what it means to be a cognitive system. So I thought it would be worthwhile starting off by just giving you a little bit of a background on what differentiates cognitive systems from traditional computing environments that are being used in most of our organizations today. So if I start off there, I'm going to talk about three key differentiators of cognitive systems. The first is the ability to understand natural language. When we communicate with each other, when we look at and have to read through regulation, when we send emails to each other, when we look up information on our customers, this information is all in a different format than our computers are used to dealing with. It's not in just numbers and bits and bytes, but it is in this natural language. So in order to be able to deal with that information, cognitive systems have evolved to be able to interpret and understand the concepts of what is being talked about. This isn't about just identifying keywords and doing traditional searches, but actually understanding what people are talking about, even understanding the tone of their communications. And you'll see some examples of how that can be applied. The second area is around reasoning. And we talked about this earlier, and I think Marc mentioned both the pros and cons of having conflicting information, and I'm sure none of you have seen that in any of your regulation. But this is one of the challenges we see in financial, in risk and compliance and regulation, is that there are often conflicting sets of information, or there are facts out there that maybe might lead you to different conclusions. So cognitive systems have enabled organizations to go beyond a rules-based approach. This isn't not about having something that says, if this, then that. And people often equate things like Alexa and Siri to doing true artificial intelligence. But behind the scenes, most of them, at least the way they got started, were really, if you say this, this is what happens. Pretty much rules-based. But cognitive systems have to go beyond that to reason and deal with information that may not lead you, different sets of information that may lead you to different conclusions. So reasoning is the second key thing. And the third one is about learning. And this, again, is going beyond rules. And what we see in any environment, whether it's around market abuse, whether it's new regulations that are coming up, whether it's money laundering, techniques change continuously over time. And you need to continue to learn things. And that means not having predefined rules. And I'll share a personal example of how this applies. I walked into, when my kids were going to a new school, and they had to sit in on how the teacher was teaching. And the teacher came up and said, "How do you spell cat?" And one kid raised her hand and said CAT. And the teacher said, that's one way you could spell it. And I was like, what? No, that's how you spell it. And she's like, well, what are other ways you could spell it? And they talked about, and obviously this is about phonics and a different approach. But the point is there isn't always just one answer, and you can't pre-program systems to know what that one answer is. You need to be able to learn and identify things in new ways over time. And that's another critical component of cognitive systems. So I wanted you to have that kind of in the backdrop as we start going through some of these things. So key aspects that are differentiating are being able to understand natural language, being able to reason and deal with conflicting information and or incomplete information, and of course being able to learn over time and make adjustments. So if we go through this, now's the first part of the audience poll. Before we get into how we're using this, I was going to ask the group this particular question. So for those of you that go to the Slido app, you should see this on your screen now. So basically the question is, and if we can cue the music, which of these is your top compliance challenge? Managing regulatory requirements, B, market abuse and manipulation, C, know your customer, D, anti-money laundering, or E, data privacy and security. So if you guys can go ahead and ping in and tell us what your So of course we had to use the Jeopardy music, given that's how we base this. But now let's switch over. So here are the results, as many of you can see. So interesting, not surprising today, given a lot of the comments around cybersecurity, data privacy, and security. Interesting that managing regulatory requirements was one of the top areas people brought up. So I thought that might be a good background to have an understanding and see where people are focused. So we'll kind of think about this as we go through how and where we're actually applying it. But what I wanted to do is give you an idea of where exactly we see opportunities to start improving regulatory compliance. And the first one that you did obviously all identify as your top priority is around managing regulatory change. I'm going to talk about this in a little bit, but with regulations constantly changing, and there's a lot of debate, especially in the US with the current administration, about whether or not regulations are going to increase or decrease. Regardless of what happens, we know there's going to be change. And that's the challenge that many organizations are dealing with. So this presents a huge opportunity to go in and try and understand what those regulatory obligations are of your organization and figure out what controls you have to put in place. So this is a huge opportunity to apply cognitive technology. The second area is around conduct surveillance. Now, interestingly, this started out more around looking at trade surveillance, because you deal with a lot of the situations and challenges that we just talked about that cognitive is perfect for. You have a lot of incomplete or conflicting information out there. You have different sets of information that are driving different directions. You're dealing with a lot of unstructured information, emails, communications, voice, things of that nature. But what's interesting is we've seen this go beyond trade surveillance to, and I heard some people talk about this at the dinner last night, getting into sales practices and other conduct issues. So there's a broad set of conduct issues that organizations are facing. And I'm wondering if I'd change that second answer to talk about sales practices, if the responses might have been a little different. And the next area, I'll sort of combine the next two areas, which are around KYC and AML. So these are the other two major areas where we see an opportunity to apply cognitive technology. Know your customer, there's increasing requirements on increasing levels of due diligence, then the types of customers being able to do or being required to do enhanced due diligence, not just on your high-risk customers, but medium and potentially even low-risk customers, increased levels of beneficial ownership requirements, other things that require you to collect a bunch of information that's out there, again, often unstructured and often that can point in different directions. And then, of course, money laundering, we heard that talked about earlier today. So one of the key requirements, though, to apply cognitive technologies to any of these domains is to have the expertise, because cognitive systems are basically taught. which means they need to learn, and they need to learn from people that are experts in the field and in the systems. So a lot of people, as we started going in and deciding to make investments in building out artificial intelligence and cognitive technologies that could be applied towards regulatory compliance, we did have the concern of, does IBM have the expertise? Now, I'm sure a lot of you are aware that we went out and acquired Promontory. That was the reason that we went out and acquired Promontory, because we recognize this same thing. And I think it's important as you go in and look at applying these technologies within your organization, you think about how you're going to apply and leverage that expertise. We've seen some horrible stories from the Microsoft chatbot and other things of machine learning without control and without having the experts driving it and teaching machine what it should and shouldn't deal with and how to respond to that information that it collects and gathers. So that's a critical part. So we've been kind of basically injecting Promontory's expertise into Watson to enable us to address these solutions. So I am going to jump now and start talking about and start doing a demo of some of these solutions. So the first one I wanted to talk about is regulatory change management. Did a little research and I switched this to deal with the Canadian regulation, but many of you probably know this. There's over 760 pages in the Canada Bank Act. It includes over 112 different regulations. That's just the Bank Act, not all the acts that are out there from OSFI. But obviously this is just one thing you might have to deal with. Other regulations that are going to make their way here, or if you're dealing with other areas, are things like MiFID and MiFIR that are big things that are out there, especially in the EU right now. Just MiFID and MiFIR have over 700 pages of regulation just for those regulations alone. And what you may or may not be aware of, there were 51 amendments within a 2-year period. So constant change going through this. Now, these numbers are actually small, as many of you know. When you look at the US federal regulation, there's over 10,000 pages just in Title 12 alone of the US Code of Federal Regulations that is kind of like the equivalent of the Bank Act. So I guess they need 10,000 pages to say what Canada has been able to say in 700 pages, but that's a different statement. And by the way, the one thing I noticed is the 700 pages actually includes both French and English. So probably have done an even better job of narrowing it down. But these regulations are constantly changing, and you need to keep up with them, and that's the challenge we see organizations facing. Having to read through all these regulations. Someone made the comment earlier, this keeps lawyers in business, keeps them active, but this is the first area where we see an opportunity to apply cognitive technologies. Now, what we've done in particular is we've started taking all these regulations and feeding them into Watson. So we're literally taking the regulations, running them through a cognitive system. And then what Watson is actually doing is it's going through and highlighting, I don't know if you can see the yellow highlights popping up, within the regulation, what are the potential obligations that a firm might need to address. You're never going to be able to rely on a computer to tell you what your obligations are. So I want to kind of set it straight there. But the idea is to tell you what your obligations might be. For any of you that saw Rodney Dangerfield in Back to School, went to the bookstore, and there was the joke about why would you buy used books? And the answer was because they're already highlighted. So that's in essence kind of what we're doing here with Watson, is we're pre-highlighting the regulations for you. Now, just like if you in college go to buy a used book, you want to make sure the person that highlighted that book got decent grades on the test. And again, that's part of why we acquired Promontory. So we had people that were decent at it and hopefully are able to help us figure out how to highlight it. So again, I'm going to switch over to an audience poll to tell you the types of things that we're having to do and that you might need to be able to ask Watson for. So I'm going to switch over now. And if you go back to slido.com, I'm going to ask you another question here. Which of these do you think is an obligation financial firms with trading operations will have to comply with? A, place GPS trackers on all traders. B, hire private investigators to spy on traders. C, hire a fortune teller to look into the future to identify traders who will commit insider trading, like in the Minority Report. Or D, maintain systems and procedures to detect and report suspicious orders and transactions. So let's switch over. And it looks like most of you have gotten that right. Great job. I kind of like the idea of placing GPS trackers on traders, but great job there. So what I'd like to do is show you now how you would leverage a system like Watson to actually go through and do this. So what we can now do is, as I mentioned, we have put in all these obligations into all these regulations into Watson. So we can now ask Watson, what are the EU obligations for market abuse? And when we ask Watson, it'll pull up all the potential obligations that are relevant to market abuse, things of that nature. And then we can jump in and see the specific details. And of course, those of you that answered the last one are correct. Any person must maintain effective arrangement systems and procedures to detect and report suspicious orders and transactions. So what we're doing is we're going through to highlight those things. And again, we could click on here and it'll actually pull up the actual regulation and show us within the regulation exactly what that is. The other thing that we can do in here is we can also identify the relevance of this to our organization, because again, not all obligations or requirements are treated equal within an organization. So you can actually go through and do a few things. One, tag those obligations to identify what parts of the business they're relevant to. Are they more relevant to trading and sales, retail, commercial, things of that nature, and what specific products. You know, in MiFID you have certain rules around derivatives that are different than FX or equities trading. And also, what are the compliance themes? Is this related to capital adequacy, or is it related to consumer protection, things of that nature? And then you can identify the scope and maturity. So we can go in here and say, okay, for our securities trading in Germany, we're doing a lot of trading in Germany, so it has high materiality. We're not doing much in Spain, so the materiality is very low in Spain. And that can then drive what kind of controls you need to put in place to address these regulations. And that's the other main challenge that we've seen from organizations, is it's not just understanding what the obligations are, but it is also what controls do you need to put in place to make sure you're addressing these obligations. So now we are going to switch over to the next polling question and test you guys on this and see if you do as well as you did on the last one. So the question here is, which is a key control to automate detection of market abuse? Again, is it mandating probiotics and yoga for traders, requiring traders to invest in index funds, identify traders that executed a certain percentage of overall shares with a significant price improvement over the closing price, or D, place shot collars on traders? So let's see. Where people ended up on this. Okay, I'm a little disappointed that more people didn't pick place shot collars on traders. I have to admit, when I did this once, 80% of the answers were on D, so maybe they had a little bit less love for their traders. But yes, this is obviously a little bit more of an obvious one, but again, the idea is we can now go in and do a search for what are the controls required for preventing market abuse or monitoring market abuse. And then again, we can then see what are the specific controls that we have out there that could be used to do this, and then even see the lineage of these controls back to the regulations that they actually support. So we can go in and see here are the specific regulations that they address and support, and get lineage to know what controls are in place. And this is another challenge we see with organizations, is you have tons of controls in your organization already. I remember I met with one of the banks here in Canada that I won't name, but they said they had around 10,000 controls in place when they knew that they probably only needed maybe a fraction of those controls in place. And what happens is, as these new regulations come up, typically what happens is people then create a project team, go figure out what we need to do to address this regulation, and then go and create a bunch of policies and procedures, put in place controls to address that. When you already have other controls in your organization that may be fairly applicable, and you could just tweak to address that same regulatory requirement. So the goal here is to enable you to go identify other controls that may be somewhat relevant to this same requirement that you could tweak or modify to address that requirement instead of having to go and create a bunch of new controls. So I'm going to switch over now to conduct surveillance and show you how we're applying Watson and cognitive technology in this particular space. And in this particular space, what we are seeing, again, is a lot of challenges around how you identify insider trading. So in here, I'm going to switch over and do another poll. So which of these are most likely to generate alerts about potential insider trading? So in your current systems, what do you think is more likely to generate an alert about insider trading? Selling a stock right before there's a significant drop in price, abnormal order sizes, getting an email from someone at a firm that the trader has a position with, or receiving a low annual bonus? So number one answer selected by everyone was a significant selling a stock right before there's a significant drop in price. Now, what's the problem with this answer? Isn't that what you pay your traders to do? To make money and time the market and things of that nature? Yet we always generate alerts when something like that happens. Any of these individual things can drive a lot of false positives or signals. So I'm not going to do a polling question for this, but can you tell what this is with only a piece of the picture? You guys have probably played these games on your iPhone where they move certain parts of the picture. So heard OWL, most people can figure out what this is. Can you tell what this picture is? What's this picture? Coffee cup. So, but here's an example of where only seeing certain parts of the picture may lead to different conclusions. This is the same picture you were looking at. And that's often the same types of challenges we see in conduct and surveillance solutions. So this is part of what we are trying to address here in our solutions, is you really need to be able to, and that's part of the benefits of a cognitive system, you need to be able to take in multiple inputs and weigh those and reason between those different things to figure out what things you should be acting on. And this is a great example of something that combines a lot of the different technologies and solutions that I talked about at the beginning, the reasoning, the natural language, and the learning. So one of the things that we can do is we can read through emails and communications, chats, whether the Bloomberg chats, et cetera, and we can identify the tone and the patterns of speech of the individuals at the organization. We've actually done this. If we have like 200 tweets, we've generated a profile of, think of it as a Myers-Briggs profile of what the personality is of the individual and how they communicate. We have some interesting things where we did this on Oprah Winfrey and the Pope. People keep asking us to do this on Donald Trump, but we're kind of afraid to try. But what we're doing is we're analyzing these communications. We're identifying kind of the tone in the communications. So what you can see in here is we're identifying if the communications are happy or sad, if they're being aggressive or conservative, if there's anger in their communications or joy, things of that nature. And we've been able to then identify what their normal pattern is and how that changes right before misconduct. So we did an interesting study with a client that we worked with Promontory, where we found that traders in the US, their use of profanity went down right before they were involved in misconduct. Maybe they were trying to hide things of that nature. So that's one example. However, we actually found that use of profanity in traders in the UK went up right before misconduct. So I won't comment on the cultural differences there, but those are the types of things that you want to be able to take into consideration. So what we're doing is we're looking at what is the profile of the individuals, what are their communications, but we're also looking at other things, their trading behavior. What lot sizes do they typically trade in? What's the frequency of their trades? What's the dollar amounts? All those sort of things, and then learning what their typical behavior is, and then identifying abnormalities or certain patterns of behavior that are highly correlated with misconduct. So we can take into account all these different things and identify potential cases of misconduct and what they might be. So in this case, we're actually going to look in and see that Mike Cohen is very likely involved in insider trading. Now, why do we think this? Again, we're looking at all these different factors, not just one, and we're building up a risk profile. So we go in and look in this reasoning graph that there's some trade risk. So we look at the trades. Just an HDMI problem, not a Watson problem. We look at the trades, and we see in there that maybe he has a suspicious trade sequence that might have been generated by our typical system, trade monitoring system. We notice a significant price change alert, but we also notice an abnormal order size compared to his normal orders and some events in close proximity. So if we look in here, we can see the details. It shows the different activity across these different things. We see that Mike has just sold 1,000 shares of Seattle Pharmaceuticals right before the market, right before a significant price drop. That again is just one signal though. We're not going to generate and make that alert, and I'll show you how we do that just based on that. We'll also look at the communications. So when we look at the communications, again, we're looking at not just keyword searches, but the tones and other things. So we will look and pull in things like SEC train violations and anomalous language use, like I talked about. But we'll also look at if he made communications in close proximity to the trade. Now, obviously, he's talking and sending emails and receiving emails every day. So he's going to have emails in close proximity. But how do you detect if there's any that are of relevance? Just doing keywords isn't enough. But we identified based on the tone of an email, and I'll read this for you, that Mike got an email from someone at Seattle Pharma, and it might not have even been at Seattle Pharma, saying, "Another day in Seattle. Hey man, I think it's going to rain here in Seattle. You better cover up before you get drenched." Now, obviously, no keyword detection would have pulled or noticed this email, but we've identified a warning tone within the email that came in close proximity to a trade event. And that then links it together and increases the likelihood. And by the way, the other thing we can look at are other things that drive motivation. So for example, we might see that indeed Mike got only 65% of his annual bonus. So that is another factor that may have been driving some motivation of him to act. You know, we can see disgruntlement, other things like that. Now, one of the banks complained to me, or basically argued with me and said our traders are always disgruntled, so you're not going to be able to use that as a key. But I think you get the point here. Now, the other thing, though, we can see is these factors, as I talked about before, each of these alone is just a signal. And the idea is, how do you pull together these different signals? So what you can actually do is play back over time how the system worked. And this is an important aspect that we've actually learned. It started, believe it or not, in Jeopardy, but then in healthcare. When we first applied Watson to the healthcare industry, we saw that if we gave a doctor a diagnosis and said, we think this is what it is, do you think the doctor really was going to believe a computer telling it what the diagnosis was? They didn't have that trust in the system. So what we found is we had to not provide just the answer, but we had to provide all the evidence. So instead, we would show a bunch of evidence, other notes that Watson had based its decision on, and said, here are 2 or 3 things this might be, and here's all the supporting evidence and the reasons why we think this is happening. And that made a huge impact and got them to start adopting the system and got them to gain trust in the system. Now, fast forward, we found this was a perfect analogy to regulatory compliance. Is a regulator going to believe you if you say, hey, the computer told us this person was involved in insider trading, or the computer told us this wasn't really money laundering? They want to see the evidence. So what we're doing throughout all of this is we're collecting evidence and generating and providing evidence to the individuals to help them make that better decision and to document it for that compliance purpose. So I can actually play back over time, and I can see how, if you looked at it, said we had like a 90+% likelihood that Mike Cohen was involved in insider trading. Now, it didn't start off like that. At first, we got one signal, which was his low bonus payment, and that came in. And it just generated a signal, but that alone doesn't necessarily drive up the percentage or make us act. Then we see some other communications that may be indicative, or some change in trading behavior that may be indicative, but again, maybe that alone isn't enough. And then over time, as we see that specific trade happen and we see that email come in, you can see that one red dot here in the communications. Those things then combine to take this over a threshold and say, hey, this is something that you should really look at. And obviously you can play around with those thresholds and you always have the evidence over on the other side. So this is a great example of how we are applying cognitive capabilities in the surveillance. And the one other thing that I'll show you here is we have expanded this to address sales conduct issues. So just like you look at the different factors that might be indicative of potential insider trading, you can see there are other factors that drive potential sales conduct issues. So for example, account activity is a great thing that you can look at. And things like enrollment reversal, mismatched contact info, high dormancy, notification suppression, suspicious logons, things of that nature are all things that could generate signals in here. You could look at other things that could be suspicious communications, even things like sales performance, seeing, did the rankings of one individual or a few individuals all of a sudden jump significantly. They used to be one of the bottom or mid-tier performers, and now all of a sudden they're one of the top performers. Or you see a concentration in their customer set of the accounts they're opening up. They're all with people, over 75 or 80, maybe involved in elder fraud, things of that nature. So the idea is very similar. All these different characteristics combine that can generate signals of potential sales practice issues. And I thought that the comments last night from TD were very applicable. It's not necessarily that even if you don't have a cultural issue, that doesn't mean you won't have individuals that are doing bad things at your organization. And that's the same thing that's going on with traders. You can have a great culture, but that doesn't mean you don't have bad people. And that can obviously have a huge impact from a reputational standpoint. So the key is how can you identify those people and that potential misconduct earlier on, but more effectively? Because right now, it is way too challenging. And part of the reason why it's too challenging is the same reason as we get into the next solution area that we're seeing significant challenges. So the last two solutions I was going to jump into for you here are around know your customer and anti-money laundering. So know your customer and anti-money laundering, again, if you think back to those characteristics I talked about, are another great opportunity, a great place to apply cognitive technology. And the challenge is the way these alerts are generated. This isn't finding a needle in a haystack, it's finding a needle in a stack of needles. For every 100 alerts that are generated by most transaction monitoring systems today, maybe 2 of those alerts result in here an STR or other places in a SAR, a suspicious transaction or activity report. You're dealing with 98% false positives. And the challenge is it's not like the other 98% don't have somewhat similar characteristics. So it's a very gray area, and on top of that, just because you filed an STR or SAR doesn't mean the person was actually involved in money laundering. It just means you felt they were suspicious of it. So it's a very difficult place for people to make progress. So we're going to jump to the next polling question here and see. Let's see. There we go. Hopefully, if you go to your Slido poll here, what do you wish you could learn to better manage your customer risk that's too time-consuming or manually intensive to identify consistently today? Their high school GPA, their favorite color, confirmation of their identity, address, industry, and potential negative news, or if they're a cat or dog person. Which of these things factor into your risk models? So again, most people got it right, although I'm sure some of your models do take into account cat or dog people. Although it is interesting, we've seen some interesting, demographic or other behavioral characteristics that can actually be used. But so as we go through and look at what we're doing in KYC and AML and where you can apply it, what I will say is it really ranges between a few different areas where you can start applying cognitive technologies. Because today, for the most part, transaction monitoring systems are very much rules-based, that middle portion where they're generating rules. So the first place that we saw an opportunity to apply cognitive technology, and this is all around improving the efficiency and effectiveness of your current systems, is really around how you deal with that onboarding of those customers, and how you deal in particular with a few characteristics of what you have to do, especially for the higher risk customers in that enhanced due diligence. And there's potential to extend more broadly, but there's a few things that we can do. We can use more intelligent robotic process automation. A lot of people talk about robotic process automation today, RPA. It's another one of those buzzwords, but to me it's just another word for screen scraping, is all it really is doing. But if you can add intelligence to it and not just take the data from the other systems, but read through it and understand it, that can add value. And then also being able to apply text analytics and understand the concepts and terms within the underlying information. Those are some of the big areas where there is opportunity. So I am going to switch over here, and we will switch and show what we are doing now with Watson and with cognitive technology. So what we're actually doing is we're looking at two sets of things in particular where we've seen an opportunity to apply this. The first is on the verification of customer information. Today, what you do is you go out to a lot of different sources, whether it's Dun & Bradstreet, Dow Jones, et cetera, and you pull information to kind of verify that the information the customer gave you is correct, or you go to country registries, things of that nature. Those are all things that can be automated and drilled down on. So what we've done is enable this to go out and connect directly to those different sources and pull in the data from the sources. So you can see the specific company information and pull it directly in. So the idea is that you can pull in on the institution or the individual any information directly from those different sources. Instead of having to go out, copy that information, retype it into your systems, you can pull it in electronically and have it automatically fed in and validated and verified against the information that you've collected from the company. And this can extend to a broad set of information from their industry, verifying the industry they're in, organizational details, beneficial owners, things of that nature. We've even done hooks into, like Dun & Bradstreet has an ultimate beneficial ownership capability where you can drill in and see the beneficial owners. So that's one example of what you can do to verify pull in and automate the capture of information from those systems. But also when you go to adverse press, when you look at the negative news about this customer, again, what's the problem with typical approaches is they use keyword searches, literally copy in a string of keywords that they know to look for and copy them in to do a Google search, a Bing search, whatever it is, and then pull back the list of articles. And then they have to go through and read through all of those different articles that were pulled up. So the idea here, though, is, and by the way, if we actually went and shadowed due diligence analysts going through this, and what we found is no matter what name you put in, what company you put in, you're always going to see certain results that are even just sites advertising criminal records and things of that nature that will just pop up. So there's a lot of noise in the system, there's a lot of duplicate articles from syndicated content, and just because certain keywords are in there doesn't necessarily mean it's relevant. So one of the things that we can do with cognitive technology is pre-read through all those articles, filter out the duplicates, and identify and prioritize which are the ones that are really talking about financial crimes versus just happen to reference some of those similar terms. And part of what we're doing here is we're actually going through and identifying the concepts that are referenced in the particular articles. So instead of just keywords, we're identifying where there are concepts related to criminal proceedings or financial crimes or bribery and corruption or litigation, and highlighting those concepts within the article so you can see those things directly within here. So instead of just going through and having to do this, what you can do is you can pull out all the details, and again, we have the ability to go in and train and identify if we agree with the system or not on these things, so the system gets smarter and smarter over time as you go and select the content. And then throughout all this process, as I mentioned before, what we're doing is we are actually keeping the information that you've collected. You can add notes and say, okay, here's what I think about this. And then at the end, what we can do is we can automatically generate our customer dossier. So instead of having to manually do that or copy and paste it, we can automatically generate it. We say generate report. It goes and automatically saves all the stuff that we found and it will now put it into this PDF, and we have everything saved that includes all that verification information, the negative news results, and even the actual text from the negative news that are down at the bottom here that we can see for audit purposes and compliance purposes. So we see the specific articles and what they said that caused us to drive this. So that's an example of where we are applying this technology in this area in KYC. So the last one that I was going to show you and share with you is, I talked about the upfront due diligence process. The other area where you can apply cognitive technologies is around reviewing and processing the alerts that are generated by those underlying systems. And here, what we've started doing is applying things like machine learning, but also behavior analysis, being able to resolve identities, identify networks of individuals, things of that nature, and looking back at historic cases to identify what are the characteristics of those cases that led us to dismiss an alert or escalate it. What are the characteristics before we would have looked at the prior transactions of the customer? We'd have looked at information about the counterparty, various sets of information. These are all things we can have a cognitive system go and do for us, to go and check all those things for us. So that's sort of what we're doing here. So now for the last polling question we are going to ask here, ask you my final polling question. Which of these things do you think would help you quickly identify an alert as being a false positive? The customer is on the TSA pre-check list. Counterparty of the transaction is Robert Mugabe. Prior alerts for similar transactions from the same customer have been dismissed. Or the description field in wire transactions says special funds for Mother Teresa. So let's switch over and see what. Okay, prior alerts for similar transactions, and with Mother Teresa a close second. So again, these are the types of things that a system should be able to automatically do for us and should be able to surface. So what we are doing here is we are actually going through, and as an alert is generated by your standard transaction monitoring systems, we're actually going out and identifying what we refer to as exonerating or aggravating factors. Think back to kind of that reasoning graph you saw. There's various characteristics of the transaction, the customer, the counterparty that can give us insights into the likelihood of this being truly suspicious activity that should be reported. So what we will do is we'll look at, for example, prior alerts here and prior cases and look at the transactions. And here we can see that there's an exonerating factor that this same customer, Chad Appleseed, had 3 prior transactions triggered for a similar scenario, high velocity, where they were all closed. They also had low-risk geographies involved, and maybe we also see that the transactions this person is conducting is commensurate in nature with the typical transactions of the person in that profile, in that age group, in that demographic, whatever it is. And then what I can do is I can jump in and view the details. So I can go in and see here were the prior alerts that were closed. And if I agree with this, I just click on Add Insight to Narrative. I can see the geographic location, other factors. If I agree with it, click Add Insight to Narrative. And at the end, I can then automatically generate the narrative to send back to my case management system. So we'll pull in the specific insights. Now this is again where some of the learning comes in. If the analysts continue to agree with the exonerating or aggravating factors that Watson generated, then we will build up more and more confidence, and the alerts and the signals will have a stronger impact on the recommendation. And if people don't agree with it, you have the ability to unlearn. And that's another important characteristic of cognitive systems. You need the ability to unlearn things also. So if we identify certain factors that we think are highly correlated, but people keep rejecting it, over time we'll reduce the confidence and reduce the impact that has on the recommendation. So likewise, we can go over and look at other alerts. So here's an alert generated by Pizza Dough Inc., where we found a bunch of aggravating factors on the other side. So the idea is, can you quickly identify what are the false positives and get them out of your queue, But likewise, can you quickly identify those things that are truly suspicious and automatically escalate them and not have your folks spend as much time on them and let them go straight to investigation? And here are some other examples we can see. So here for Pizza Dough Inc., we can see that there were potentially related parties that were involved in other escalated alerts. And if we drill down, we can see in here, it indicates that there were customers using a similar address, the same address, that were involved in other escalated alerts. So this generates an aggravating factor because we've seen prior alerts for another company but using the same address. We can see the counterparties involved. So maybe this customer, Pizza Dough Inc., is sending money to Jane Smith and Donuts and stuff, both of which have been involved in a bunch of other escalated alerts. So the idea is to pull in all these aggravating and exonerating factors to help us make a determination of which things we should be spending time on and which things we should just get rid of from our queues. But in all of these things, as you can see, what we're doing in the key factor here is, or the key requirement here is to provide the evidence to the individuals. And that's why today what we would say is, in reality, we don't talk about this as much as artificial intelligence, but in this space it's really about providing augmented intelligence. How can we augment the intelligence of the individuals that are performing the work, doing the activity, and enable them to be smarter? How can we enable our analysts, our the legal team, the people that are supervising our employees, how do we enable them to make better decisions faster? And I think that's really where the promise of cognitive lies. It's not going to be in just completely taking over those activities, but how do you enable people to do things more quickly? So I think with that, I am complete here. So on time, how are we on questions? Do we have time? Okay, so we have time for a couple of questions.
I was just wondering, you've described, bright future. We have a cognitive tool, artificial intelligence, Watson. I was wondering about the health check of this cognitive tool, because, for example, if a number of politically exposed people with unlimited funds plant a virus in your tool, so this cognitive check just cannot see those people. And it just misses them all the time they're doing their due diligence. So is there any idea how this health check can be implemented, or is it being implemented?
I would say it is being implemented in that, and it's sort of what I talked about earlier. You have to be very careful about how you leverage, AI cognitive technologies, in that you can't just rely on pure machine learning or unsupervised machine learning. And what we have found is it's critical to take an approach where you combine different techniques and you constantly have the experts kind of reviewing and doing things. I mean, it's no different from how you do model validation today. We actually do kind of similar type of approach where you're doing model validation on the output of Watson in this case, but any cognitive system, you can't just put out there and rely it to work on its own. They are expert-guided systems, if you will, and you need the experts that stay engaged and involved to continue working with the solutions so that they are constantly looking at and providing feedback to the system. It's a continuous learning process, and it has to be guided by those experts, not just let to run amok, in which case you can run into those challenges. A question over here?
I'm interested in the big data that Watson is processing, and just for this demo, how much data was consolidated together?
Well, there's a bunch of different elements here, and when you look at the data collected, and what I would say is, there's two things that can make a cognitive system better. One is, more data. So the more data you can plug in is going to make it better. But just as important is, clean or accurate data. And those things can actually impact a system negatively if they don't have the right data. So for each of these solutions, what you see is it is dependent on being able to go and get certain types of data. And that's also why I talked about and shared that image of the coffee cup owl. I mean, because you can generate, you have to be careful in what types of signals and how much reliance you put on each of those individual signals. You can start generating signals with smaller amounts of data. So for example, in the trading example, we started off just pulling in trade data and emails and chats. And that was enough to at least improve what they had today. But then as we started pulling in HR data, voice surveillance, so we can record voice conversations and translate that, then you start getting and improving the accuracy. So I think that's the key. In each of these, it's different. I think in the KYC solution, we actually showed there were we actually go across the entire web to pull in and do the initial search, but then we take the results, which oftentimes, as you saw in that case, I think there were 16,000 pages of results that we then filtered through to get through what were the ones that had the concepts we wanted to focus on.
In the use of cognitive data, you talked about how you're managing regulation in the use of cognitive data. My question is on the flip side, how is it that you would ensure, especially as it relates to conduct surveillance, that you have guardrails around cognitive data and the use of the technology? You know, you mentioned, I know I read somewhere too, you know, typically there's a pattern of if an employee has been not promoted, they tend to, you know, participate in more unethical conduct and, you know, but just using that kind of employee data as it relates to an employee in an organization, what are the guardrails you have around managing that?
Yeah, that's an important question, and it also drives where you can apply some of this technology. So for example, the conduct surveillance solution that you saw, where we have had the most success with it is where we're applying it on regulated employees, i.e. traders, where you do have the ability and the rights to monitor all their communications, all of those activities. Just applying it to your normal branch employee, others, you have more challenges. So the first thing is, it does drive where you can apply this, and that's why trade surveillance was one of the first areas. And then as you saw in the sales practices, there was less of a reliance on the communications. It's more looking at the facts that you do collect today. You know, what happened with the accounts they opened, what's going on with their sales performance, and looking at other management communications and other things that may be more cultural issues. So for all of these things, and obviously, GDPR is driving how much and what you can use the data for in Europe, and there's different requirements. So it is going to drive that. You know, the U.S. is one of the easiest places to, leverage a lot of this information, and but again, it's just going to drive what data you feed into the system and what you use it for. So I think we'll take one more question.
Can you describe for us some of the differences, please, between applying cognitive systems in a regulatory environment that's rules-based versus one that's principles-based?
It's a great question. When we first started feeding regulations into Watson, what we found is, and actually it's an important factor across all these solutions. And someone kind of asked about, when a person talked about blockchain, they said there is no the blockchain. In a similar fashion, there is no the Watson. What we found is we have to train Watson differently for different domains, different set of, there's a different backend for Watson that serves financial services than healthcare, but even within financial services, what we found is we trained it on reading the regulations, being able to understand what are the potential obligations in a regulation that's more principle-based versus something that's very directive, and laying out specific requirements, and even something like MiFID where they lay out specific rules that say, okay, here's the calculation for these things. I didn't highlight it in the solution, but as you go through, you can identify if things are requirement or guidance or calculation details or things like that. But basically the net is we've had to train Watson to read things differently. In surveillance, when we were analyzing communications, we found that traders have their own communication, their own way of, their own language. And even within trading, FX traders talk differently than equities traders. So what you end up having to do is train it to the different areas. In the financial crime space, we had to train it on a different set of concepts and entities. So racket can mean a bunch of different things, from being related to tennis or making a lot of noise, or a crime racket or whatever it is. So you have to train it to understand the context and the different terms. And that, again, just in any cognitive system, is part of the biggest effort up front, is really training the system to understand the domain that you're applying it to.